Okay, so today we're going to be looking at solving natural log equations and exponential equations with bases of e. So the first thing you need to know is that if you see e to the x, that is the inverse of the natural log function. So these e to the x and natural log of x are inverses. And the natural log of x can always be rewritten as log base e of x. So that's going to help us solve these problems. So for me to get my x to come down, just like last week we took the log of both sides, but since this is a base of e, we're going to take the natural log of both sides. So natural log of e to the x equals the natural log of 5. That x will come down in front. If you type in your calculator natural log of e to the first, you'll see that that is equal to 1. So you get x equals the natural log of 5. And then we get our calculator. A natural log can be found right under the word log. So you'll hit natural log 5 and hit enter. So 1.609. This next one, I have to get my e to the negative 2x by itself, so I would divide both sides by 4. I will take the natural log of both sides. Again, the negative 2x will come in front. That will be 1. I'm left with negative 2x equals the natural log of 2. And x equals the natural log of 2 divided by negative 2. So coming over to my calculator, natural log of 2, make sure you close those parentheses, divided by negative 2. So we get x equals negative 0.347. On C, again, we want to get the e to the x by itself, so we'll add 4 first. And then we would divide by 3. And then take the natural log. X comes in front. That's 1. Type that in my calculator. Natural log of 8, 2.079. Now remember, natural log we're going to rewrite as log base e of x. So log base e of x equals 5. We'll convert that to exponential. So that's my base, that's my power. And that's what it'll equal. So we'll go to my calculator. The e can be found by hitting second natural log. Type in the 5. And we get x to be 148.413. Again, you can always check these answers by plugging them into the original equation. This last one, before we get to the word problem, you're going to add 4 first. Divide by 3. Rewrite as an exponential. Rewrite as a log base e. Then write as an exponential, e to the power of 3 equals 2x. So x will equal e to the power of 3 over 2. So second natural log to the power of 3 divided by 2. So we get x equals 10.0433. All right, so now we have a word problem, and if these problems are on the quiz or test, I would always give you the formula that you're to use and then ask you to find certain parts of the equation. So this time, this is a formula to determine how long it takes things to, for amount of money to double, triple, or just how long it will take for a certain amount of money to become something else. So the A stands for the balance at the end of time. P is the initial balance, or the money that you invest originally. R is your interest rate, and then T is time in years. So on this particular question, it says, how long will it take $1,000 to triple if it's invested at 1.5% interest? So A is, if your money's going to triple, how much will you have at the end? You'll have $3,000. Your principal is $1,000. My interest rate is 1.5%, so as a decimal, that's 0.015, and T is what we're trying to find. So 3,000 equals 1,000 times E times 0.015 T. First thing we're going to do is divide by 1,000. Again, we want to take the natural log to get that to come down. So we have a natural log of 3 equals the natural log of E 0.015T. The natural log of 3, 0.015T. This is 1. So I will divide both sides by 0.015. So T equals the natural log of 3 divided by 0.015. So natural log 3 divided by 0.015. And you get 73.2408. So about 73 years and a quarter of a year or 3 months. But if it asks you to round to the nearest year, if you round to 73, your money will not have tripled by that time. So we would round up. So T equals 74 years. If it says to round to the nearest part of the year, you could just say 73 and 2.4 years if you wanted. Usually we round to the nearest whole year. So that's the notes on solving natural logs and exponential equations.